Thank you for the opportunity to be here. And indeed, we'll be talking today about antibiotic resistance. Now, antibiotic-resistant bacteria are killers. By various estimations, by the year 2050, they will have killed 150 to 300 million people. And there's very little innovation going on in this area. Very few new patents are being filed. Very few new drugs are reaching the market. But as horrific as this sounds, it's not the entire problem with the overuse of antibiotics. The other problem stems from the fact that we are really only half human. In our body, we host as many microbes, bacteria, and viruses, bacterial viruses, and fungi as we do human cells. And this microbiome is very important to us. It's important for our health. The microbiome assists us in getting nutrition out of our food. It instructs our immunity system and helps our immune system. It's even important for mental health. So anything that perturbs the microbiome, in fact, exposes us to a plethora of other diseases. And this is exactly what antibiotics do. They act like A-bombs. They eradicate the innocent and the good along with the bad. So really the challenge is to overcome antibiotic resistance with a new mode of action that at the same time preserves our healthy microbiome. Okay. Nature has in fact supplied us with a solution. The solution are phage, bacteria-specific viruses. Each phage has one specific bacterial target. It attaches to this target, enters it, replicates, lyses its host, and is amplified exactly where it's needed. And because it only recognizes bacteria and specific bacteria, it's very safe. It doesn't recognize human cells. And because it has a completely different mode of action than antibiotics, it's equally as effective in antibiotic-resistant bacteria as to antibiotic-sensitive bacteria. So what BiomX has done has harnessed the capabilities of phage and found ways to isolate them against specific pathogenic bacteria and to combine them rationally to form phage cocktails that together prevent the appearance of resistance on the part of bacteria to these bacteriophage. Using our approach of rationally designed phage cocktails, we can now approach a number of different diseases in which specific pathogenic bacteria have come to be recognized as contributing to disease. Our first indication is inflammatory bowel disease, where one specific bacteria called Klebsiella pneumoniae, which is very antibiotic resistant, has been shown to contribute to the inflammatory phenotype in susceptible individuals. Looking at other indications like cancer, for example, H. pylori, which about 50% of the population is colonized by that, is very hard to eradicate and has been labeled as a carcinogen by the World Health Organization over 20 years ago. So this is also an interesting target. Other cancer-related target are bacteria that are found inside tumors and are actually found to affect the behavior of those tumors, to make them better able to proliferate, to make them more resistant to conventional anti-cancer therapies such as chemotherapies. All these bacteria-based diseases are now possible to address with the rationally designed phage cocktails that, on the one hand, we know are able to overcome very successfully antibiotic resistant, and at the same time, they preserve our intact and healthy microbiome. So that's it.